Activity sheet number 9, hypothesis concerning one mean. Procedure for testing a hypothesis. Step number 1, formulate a null hypothesis and alternative hypothesis. Here we have three examples of alternative hypothesis. If mu is not equals to 100, it means two-tailed test. If mu is less than 100, it means one-tailed test or left-tailed test. If mu is more than 100, it is one-tailed test or right-tailed test. Step number 2. Specify the level of significance. Normally, we specify 10%, 5%, or 1% level of significance. Step number 3. Select a random sample and compute the appropriate test statistic. Step number 4. Decide whether to reject H0 or accept H0. Here we have a normal curve. This is called right tail and this is called left tail. Example number 1. A sample of 900 members is found to have mean of 3.47. Can it be reasonably regarded as a sample from a large population with mean 3.23 centimeter and ST 2.31 centimeter? X bar is equal to 3.47, mu is equal to 3.23, sigma is equal to 2.31 and n is equal to 900. X bar means sample mean, mu mean from the population, sigma means ST from the population. Step number 1, we will develop our hypothesis. H0 mu is equal to 3.23 and alternate hypothesis mu is not equal to 3.23. It is two-tailed test. Step number 2, level of significance which is not mentioned. So we assume it as 0.05. So Z 0.05 over 2 will give us 1.96 from the Z table. Step number 3, test statistic. Z is equals to X bar minus mu over sigma over root n. Put here all the values and we will get 3.12. Reject H0 if Z mod is more than Z alpha over 2. 3.12 is more than 1.96, so we reject H0. We can do this graphically. Suppose this is a normal curve. 1.96, it's a two-tailed test, minus 1.96 and 1.96. Right and left in the center, it is 0. And this is level of confidence, means if the value of sample test statistic falls in this region, we accept H0. Clearly 3.12 is outside this area. Minus 3.12, 3.12, this is the meaning of absolute value. Left side or right side. That is why we rejected H0. Example number 2, a stenographer claims that she can take dictations at the rate of 120 words per minute. Can we reject her claim on the basis of 100 trials in which she demonstrates a mean of 116 words with the ST of 15 words? Use 5% level of significance. So this is the information we have from the question. X bar is equals to 116, mu is equals to 120, S is equals to 15 and N is equals to 100 number of trials. Step number 1, formulate hypothesis. H0 mu is equals to 120. Alternate hypothesis, mu is less than 120, that she takes less words. It is one tail test or left tail test. Step number 2, level of significance 0.05. From Z distribution table, we get the value 1.645. Since it's on left side, so we take it as negative. Step number 3, test statistic. This is the formula. Put here all the values and we'll get minus 2.67. Step number 4. Minus 1.645 is on the left side and right side is acceptance region. If the value of test statistic falls here, we will accept H0. So minus 2.67. It falls outside this region. So it means that we reject H0. Example number 3. The SD of the tube life for a particular brand of ultraviolet tubes is 500 hours and the operating life of the tubes is normally distributed. The manufacturer claims that the average tube life is at least 9,000 hours. So our null hypothesis, mu is more than or equals to 9,000 hours claimed by manufacturer. And our alternate hypothesis is no, it is less than 9,000 hours. So we have to test the claim at 5% level of significance. Given that a random sample of 15 tubes, now the sample size is very small, with a mean life of 8,800 hours. So this is a left tail test. Step number 2, level of significance is equals to 0.05. Sample is very small, so we use t distribution. We will find the value from the t distribution table. T 0.05, 14 is the degree of freedom. 15 minus 1 is 14. We'll get 1.761. So since it is a left tail test, so we put minus sign here, minus 1.761. Step number 3, test statistic. T is equals to x bar minus mu over s over root n. Put here all the values, we will get minus 1.55. So graphically, minus 1.761 lies here. So it means that if the value of test statistic falls in this region, it means that the claim of the manufacturer is true. And if it falls outside this area, so it means the claim of the manufacturer is false. So minus 1.55 clearly falls in the region. So we accept H naught and the claim of the company manufacturer is true. Example number 4. An educator claims that the average IQ of American college students is at most 110 and that in a study made to test their claim, 150 American college students had an average IQ of 111.2 with ST of 7.2. At 1% level of significance, test the claim of the educator. So mu is equals to 110, x bar is equals to 111.2, s is equals to 7.2, and n is equals to 150 from the given question. Step number 1, we will formulate our hypothesis. Null hypothesis is mu is less than or equals to 110. Alternate is that mu is more than 110, the claim of the educator. This is right tail test, more sign, bigger sign. Step number 2, level of significance is given as 0.01 as sample size is very big. So we will use here Z distribution. Z 0.01 is equals to 2.33. Step number 3, test statistic. Z is equals to x bar minus mu over s over root n. Put here all the values. We'll get 2.04. Step number 4. So graphically, this is a right tail test. 2.33 lies here. It means This is the level of confidence, and this is rejection region. If the value of test statistic falls here, we will accept H naught. So 2.04 clearly falls in this region, so we will accept H naught. Example number 5, a company claims that the mean life of its bulbs produced is 1600 hours. A random sample of 100 bulbs gave a mean life of 1570 hours with a ST of 120 hours. Test the claim at 5% level. First, we get all the information we have from the question. Mu is 1600. X bar is equals to 1570 from sample. S is equals to 120 from sample, and sample size is 100. Step number 1 is to formulate the hypothesis. Null hypothesis is that the mean life is 1600. And alternate hypothesis is that mean life is not 1600. This is two-tailed test. Step number 2, level of significance 5%, that is 0.05. From Z table we'll get 1.96. Step number 3, test statistic. Z is equals to x bar minus mu over s over root n. Put here all the values. We'll get minus 2.5. So reject H naught if absolute value of Z is more than Z alpha over 2. So graphically, we can picture it as 1.96 to right and left, and this is acceptance region. If test statistic falls in this area, it means we will accept H naught. Minus 2.5 is clearly outside this region, so we will reject H naught. So the claim of the company is wrong. Example number 5, part B. We already have done part A. So it is same, only step number 2 and 4 are different. How they are different? The level of significance, which is 1%. So I start from step number 2, which is level of significance given as 0.01. Table value is 2.58. Step number 3, same. Step number 4, graphically if we see 2.58 left tail, right tail, if the value of test statistic falls in this region, we will accept H naught. So minus 2.5, yes, it is in this region. So it means that H naught is true. This is the end of the lesson. Thank you.